Assalamualaikum and hi everyone, especially to Dr. Nur Haziqah binti Jamil. Today, I would like to present my assignment 5 task 2 from subject Introduction to Mathematical Economics. First, let me introduce myself. My name is Nur Haziqah Hareez binti Mohd Nor. My matrix number is 286804. I am from Group A in Bachelor of Science in Economics and currently I'm in Semester 1, Session 2021-2022. In this video, generally, I will solve the problems of concavity, marginal cost and interpretation, and also revenue, cost and profit function. Let's go! The first question is, determine whether the function of fx equals to x cubed minus 6x squared plus 18x minus 15 is concave upward and where it is concave downward. Function may be concave downward if second derivative f less than 0, which means going down or negative. Concave upward if second derivative of f greater than 0, which means going up or positive. There are 3 steps to solve this problem. First step is differentiate using power rule by using first and second derivative. Then let second derivative of f equals to 0 to find the intervals. Last, test any number in the intervals to identify where concave upward and where concave downward. So the function given is fx equals to x cubed minus 6x squared plus 18x minus 15. By using power rule, we can get first derivative of this function, which is equals to 3x squared minus 12x plus 18. Then differentiate the result of first derivative and get 6x minus 12. Next step, let second derivative of f equals to 0. 6x minus 12 equal to 0, then factorize it, and we get the value of x, which is 2. Now, let's create a sign set on a number line. Let's say if we plug in a number that's greater than 2 like 3 that's stated in the table, the second derivative will be positive on the right side. If we plug in 1, a number less than 2, 1 minus 2 is negative. So on the left side it's concave downward because the second derivative is negative. On the right side is concave upward. All the way to the left we have negative infinity and to the right we have positive infinity. If second derivative of f less than 0, f is concave downward on that interval. If second derivative of f greater than 0, f is concave upward on the interval. So concave upward is on interval to negative and concave downward is on interval negative infinity to. Question 1b, suppose that the cost function for a manufacturer is given by 6x equals to 0.0000001x cubed minus 0.003x squared plus 5x plus 1000. Describe the behavior of the marginal cost function. Question B1, find the marginal cost function. To find marginal cost function, we need to differentiate of cost function so that we get c prime x equals to 0.00003x squared minus 0.006x plus 5. Next question, describe the behavior of the marginal cost function, whether concave upward or concave downward. Prove your answer. So for this question, the steps are similar with question 1a. First step is differentiate using power rule by using first and second derivative. Then let second derivative of function c equal to 0 to find the intervals. Then test any number in the intervals to identify the concave upward and concave downward. In the previous question, we get the c prime x equals to 0.00003x squared minus 0.006x plus 5. Then, to identify its concavity, we use second derivative to determine whether it is concave upward or concave downward. So we can get second derivative of c is equal to 0.00006x minus 0.006. Then let second derivative of c equal to 0 to find the value of x. Then x equals to 1000. The intervals are negative infinity 1000 and 1000 infinity. The test number can be any number as long as it is between negative infinity 1000 for the first row, then I decide to use 100. The concavity is negative. For 1000 infinity, I decide to use 2000 and then substitute the value in second derivative of c, so the sign is positive. Concave upward is on interval 1000 infinity and concave downward is on interval negative infinity 1000. Question 1c, a company has established that the revenue function in ringgit Malaysia is Rx equals to 2x cubed plus 40x squared plus 8x, and the cost function in ringgit Malaysia is 6x equals to 3x cubed plus 19x squared plus 80x minus 800. 1c1, find the level of production that will yield a maximum profit for the company. To get the maximum profit, we use total revenue minus total cost. So here we get for profit function, which is negative x cubed plus 21x squared minus 72x plus 800. After that, differentiate the function with p prime x equals to negative 3x squared plus 42x minus 72. Third step is let the function equal to 0 to get the two levels of production, which is x equals to 12 and x equals to 2. In order to get the confirmation which level can maximize the profit, we need to do the second derivative and we'll get negative 6x plus 42. Then substitute the values of x in the second derivative to know which one is maximum or minimum, where we get negative 30 in production level of 12 and 30 in production level of 2. Since second derivative is negative or less than 0, so the level of production that will yield a maximum profit for the company is 12. So for the very last question, find the price per unit to maximize the profit. We use the previous level of production that will yield a maximum profit, which is 12, and insert in the function given and divide by 12, and finally we get the price per unit to maximize the profit is 102 ringgit 67 cents. That's all from me. Thanks for watching.